Hello, this is Mr. McGovern. This is the second video in the capacitors series from Level 3 Electricity. We're going to look at what happens when we wire capacitors in series or parallel, how that changes the total capacitance of the circuit. So we'll start with a little online simulation from the FET diagram again. And here we've got one battery connected up to one capacitor, and the simulation shows us the total capacitance, how good this capacitor is at storing charge. And on the side here we can see the total capacitance, and we can change it to say 2 in series. So if I click that, I've now got 2 capacitors, and notice how the total changes. So it's down to 0.5. With 1, it's 1 times 10 to the minus 13, now it's half. So you put 2 in series, and the reason is these two parts here, let me just slow this down, these two parts here, if you were ever to unplug this and then plug it into a light bulb, with the positive and negative, because they are connected to each other, the charges can cancel each other out. So really this is the same as having one capacitor with one plate up the top, one plate down the bottom, but a bigger distance between than just having a single plate. So this becomes worse as a capacitor. If I go back to single, it was 1, and now look at a parallel, and you look at with parallel, the capacitance goes up. So single is 1, parallel twice as much. And the reason for that is now you've just got 2 capacitors beside each other. It's like you've increased the size of one capacitor. You've effectively doubled the capacitance. So you increase the area. So in series, it's like, because the middle section can cancel each other out, it's like you've increased the distance. And increasing the distance in the capacitor makes it worse, so the capacitance goes down. In parallel, it's like increasing the area, bigger plates. That increases the capacitance. And so the way that comes out in the formula is these. Now these may look similar to something you've seen before. The resistance formula that you learn in level 2 are exactly the same but opposite. So in series for capacitors you got this 1/over formula, but for resistance that was the parallel one. And for capacitors you just add the capacitors up in parallel, but in resistors you had to do the 1/over formula. Okay? So they're exactly the same, but flipped around. And you just have to be able to remember that they are flipped around from what you saw in resistors in level 2. So here's a circuit with 3 capacitors in it, and we're going to work out the total capacitance. So we'll do the parallel section first. So the 3 microfarad and 3 microfarad. And so in parallel, you just add the resistances up. So we go 3 microfarads, 3 microfarads, 6 microfarads. So now we've got the equivalent of a 6 microfarad and another 6 microfarad, and now that's in series. So the series is the 1/over bit. So 1/6 and 1/6 becomes 2/6, which is 1/3 microfarads, and you invert that to get the total. So you get 3 microfarads as the total resistance in that. The total capacitance in that. My mistake.